everybody. I am Krishna Rao Patro, Assistant Professor from the Department of Computer Science Engineering from Institute of Aeronautical Engineering College, Hyderabad. Now, in this session, we'll see about what are the different type of operators available in Java and how to use them. Actually, operator also one type of token. This particular token has to be used properly in a particular applications. When I say operator always depends on operands. Java supports various types of operators. One is arithmetic operator. Second one is relational operator. Third one is logical operators. Fourth one is assignment operators. Fifth one is bitwise operators. And the next one is conditional operator. And next one is increment and decrement operators. And next one is instance operators. So various types of operators are available in Java. How to use these operators using program? So if you observe here, you will find various types of operators. These operators I can classify into three groups. One is unary operator. Second is binary operator. And third one is ternary operator. Ternary operators. So that means this classification based upon the number of operands. Unary operator depends on single operand. Binary operator depends on two operands. Ternary operator depends on three operands. That means what? Some operator depends on single operand. That operator is known as unary operator. So Java supports various unary operator. For example, your not. Logical not is a unary operator because that depends on single operand. Similarly, the ones complement, bitwise operator. This is also unary operator. Similarly, the plus plus and minus minus, that is also unary operator. Instance of, it is also a unary operator. Similarly, they are all unary. And the conditional operator, this is ternary. And these are all unary. Okay. And remaining are binary. So in your program, you may use unary operator or binary operator or ternary operator also. Now, we'll write a program to use these operators. First, we'll go for arithmetic operators. So, arithmetic operators depends on always two operands. That's why all arithmetic operators are binary. Sometimes even in the exam, they may ask a question, how many arithmetic operators are binary? The answer is 5. All 5 are binary. What are the 5 arithmetic operators? Plus, minus, star, division and modulus. They are all arithmetic operators depends on two operands. So now we'll use a program to check how it works. Now I'll open my Notepad++ because I have to use one editor to type the program. Let us create a new one. I want to give a demo on arithmetic operators. First, whenever you want to write a program, always write comment because the comment is nothing but your documentation part. What exactly you want to do, you have to write. What is the aim of the program? To perform arithmetic operations. To perform arithmetic operation. Okay. The arithmetic operators like plus, minus, star, division and modulus. These are the operators I want to use. Okay. And for every Java program, you have to follow a particular structure. First line is your import statement. Write your import java.lang.star. That indicates what? Java is my main package. Under the Java, lang is a sub package. Under the package, there are many classes are there. So you may use some of the classes of lang package. That's why you have to import this one. Next. Then you should write the class keyword. Class, and the name of the class should be relevant to the task. So here I will write arith demo. Open bracket, close bracket. This is the way you would write. Okay, class followed by the class name. And this program having my requirement is to perform all arithmetic operations. So I will write everything in my main method. So how to write main method in Java? For writing main method, it requires set of keywords before that. The first keyword is public. Public tells that it can be accessed by anybody and anywhere. So public access. And the next keyword is static. It tells that you can call this method directly. That means the compiler can invoke this method directly. Without generally to invoke a method, you have to call through object. But main method you can call directly without creating object. That is the importance of static. So static allows to call the method directly. Next, void. The void tells the main method returns nothing. Then write main. Inside the main, you write the command line arguments. All the arguments are in string format. You may pass some set of arguments through command prompt. So pass a string arguments array. So this is the common syntax for your Java program. Open bracket, close bracket. And remember, you can write args or you may not write args. You can write any name also. Even I can write X also. That doesn't matter. But generally we will prefer args, arguments. Args means arguments. You can pass any number of arguments from command prompt. Sometimes you may pass, sometimes you may not pass. If you are not passing anything, the argument become null. The length is 0. That means you are not passing any argument. Fine. Now, I want to perform arithmetic operation. So to perform arithmetic operation, I will be depending upon some numerical data. Numeric means what? It can be a pure number or it can be a decimal number. So to perform arithmetic operation, you have to use some variable either of integer category or decimal category. So for simplicity, I will declare integer variable int a, comma b, comma c. There are 3 variables. Initially assume a is some 10 and b is some 20. Now I want to compute c value. C equal to how much? A plus b. This is my arithmetic operation, addition. At the same time, I want to do subtraction also. So for subtraction, what I will do? I will use a variable called d. And e is another variable. D equal to a minus b. And e equal to a into b. And f equal to a by b. And g equal to a modulus b. So I will be declaring multiple variable to store the result. E, F, G. Okay. So I am having 2 values a and b. Then I will compute a plus b. That result I will store in C. So a is my integer, b also integer. So a plus b also integer. That's why C must be declared as an integer variable. Similarly, D. A is integer, B is integer. Integer minus integer is integer. Then next E. That is also integer. And then next integer by integer. So here also I will get integer value. So that means you will not get the decimal point. Here you will get pure integers. Then A modulus B. Then here you will get the remainder. So if A is 10, B is 20, then what the value I will get? System dot out dot println. First one is what? Sum of 2 numbers. So I will print sum. Sum equal to. So whenever you want to print the data, then you have to use println method. In the println method, you can write a string. So the string will be always represented within double quote. So write within double quote anything. In addition to this, you want to concatenate the value of the sum of 2 number. The sum of 2 number available in C. So write plus C. This is called string concatenation. You are concatenating that string with this value. So that means it will display as a single line. Similarly, next, I want to display the difference of A and B. So you can display the difference value is stored in D. So write D. So here, instead of sum, I will write diff. Then next, the product of 2 number A and B, that is available in E. So here I will write E. So here, instead of sum, I will say product. Next, and here I will write F. F is what? Division of A and B. F. So here I'll write division of A and B. And then modulus. Modulus means the remainder. If you divide 10 by 20, what is the remainder? Because when you divide 10 by 20, the remainder will be 0. So let me print the remainder. Remainder is available in G. So here I will write here remainder. So these 5 values I want to display. Okay. So now this program I want to execute. Control S. What is the name of the program I should give? Because whatever the class name I have given, same name I have to give. Here I have given the class name as Adit Demo. This name. So always remember in Java, the class name and file name, make it always same. So that there is no confusion. Because whatever the name you have given, with that name the bytecode will be created. So the bytecode depends upon the class name, not on the file name. Adit Demo. And here you choose J. Because you are running in the Notepad++. So once you press J, it will give Java source file, save. Automatically that will store as a .java. Now you have to compile it. Where you have to compile? Wherever the program is there. How to go to that program place? Click, right click, then open into containing folder, go there, yeah. Now it is available in the Patro folder. Now compile it, Java C for compiling, Arith demo .java. Yes, the program compiled successfully. How to run? Java Arith demo. And while running, you please remove the dot class. Only give the name of the file. That is your bytecode. Yeah. Now, actually, what is the value of A? A is 10, B is 20. So, sum is how much? 10 plus 20, that is 30. Then 10 minus 20, that is minus 10. 10 into 20, that is 200. 10 by 20. Actually, 10 by 20 in normal mathematics, generally 10 by 20 means 0.5. But in your Java, when you say 10 by 20, because 10 is integer, 20 also integer. So, integer by integer is integer. So, it will take only the integer part. So, the decimal part will be omitted. So, it's supposed to be actually 0.5, but the 0.5 will be removed. Only integer part will be taken. So, that's why answer is 0. Then the modulus. Modulus is what? 10 modulus 20. When you divide 10 by 20, the modulus is, that is, because when you divide 10 by 20, automatically the quotient will be 0 and the remainder is 10. So that value is, when you write 10 by 20, 20 0 0, so remainder is 10. So this is the modulus part. This is the modulus part. Okay. So this way you can execute. Now I'll give one more. For example, this is in terms of integer. Sometime you may need some float data. If A by B supposed to be in float. So if you want to store in the float, what you have to do? You declare that variable f is a float type. Float f. So that means here I will remove from integer part. So if I remove this from integer and kept it float, here what happened? A by B. Actually A is integer, B also integer. A is integer, B is integer. But integer by integer is again integer only. But you are storing in float. But actually your intention is what? The data is supposed to come in floating format. So if you want to get in float, then you need the integer data has to convert into float type. For that you need a type conversion. So you convert into float type. Float up here. That means one of the data is float. This is called explicit typecasting. A by B. So that gives you the float result. That value is now stored in F. Now My left hand side is float, right hand side also float. So that I will get in the floating format. Now please observe here. If I execute, now go to command prompt, execute, compile it. Yeah. First I will clean the screen. Java C, arith demo, compile it. Java, arith demo, remove the dot class, enter. Yeah. Now here you got 0.5. Earlier you used to get 0. Now you got 0.5 because I made the data to a float type. Okay. That's why whenever you want to have floating value from integer, then better you go for typecasting. This is called typecasting. You are converting the integer data to float type. Okay. Convert integer to float so that your answer will be in a floating format. Fine. Now, same data, or I may give different form. For example, instead of, I will give here 17 and here I will give 7. 17 and 7. Now what is the answer now? Again compile it. My data are changing. Compile it. Run it. Yeah. So the sum is 17 plus 7. 24. 17 minus 10. That is 10. 17 into 7. That is this. 17 by 7. That is 2.4 this. And remainder is 17 modulus 7. 17 modulus 10 means how much? 17 modulus 10. When you divide 17 modulus 7, that means what? You are dividing 17 by 7. So 7 to the 14. So remainder is 3. So this is the answer. That is for modulus. So in your screen you got how much? 3. Yeah, remainder is 3. Okay, this is the way you have to compute. But here you got how much? 2.4285715. Very lengthy value. But I do not want to display up to this 5 digit. I want to round up to 2 digit. How to round off? I do not want to display after decimal 5 digit. I want to display up to 2 digit only. So in that case, you can use instead of this statement while division. Here I'll put in comment, Control C. I'll put instead of println there is another method called printf. So better use printf. In the printf, you can use a control character called percentage is a control character. 0.2, that means after decimal 2 digit. 0.2f. After decimal 2 digit. Followed by, you should give a comma, followed by f. Now for same data. Now observe here, again I will compile. Compile it. Run it, yeah. Now see earlier, how much you got? 2.4228 this month, lengthy number. Now here I rounded off. After rounding up, I will get 2 digit. But after 2, 8 is there. So when you round off, then it will be rounding out to next highest digit, that is 3. So 2.3. But the remainder actually supposed to come to next line. But it's coming in the same line. So you have to send the control to next line. So how to send the control to next line? For that, there is a escape sequence character. You can use \n so that next time that statement will come next time. Compile it. Yeah. Now, yes. Now I got in 2 different lines. Earlier it was printing in same line. Now I'm printing in 2 different lines. So this is the way you can print. Because most of the time in the coding, online coding platform, they will be asking you to display the data in a 2 different lines. In that case, you can use the base class n also. Or sometimes they may ask you print the decimal value up to 2 digit or 3 digit. If it is 3 digit, then how will you do? If it is after decimal 3 digit. In that case, you can write 0.3f. Here you can change 0.3f. Now see, if you see 0.3f, compile it. Yeah, now I got up to 3 digit. So this is the way you can change. Okay. Most of the time, especially in the coding platform, they will be asking display up to 2 digit or 3 digit after the decimal. In that case, you can use the printf method. So these are println for printing the string purpose, printf for printing the data in a formatted. So whenever you want to display with your own format, with your own requirement, in that case, always go for printf. So now you have seen what? The arithmetic operators. Anyway, day by day, in future exams or future programs, you will be using all the arithmetic operators for different calculation purpose also. Now we'll go to next two operators, that is relational operator. So please remember, in arithmetic operators, always the result is numerical value. The numerical value means what? It can be integer or it can be decimal value also. Control N, Control A, Control C, Control N. Now we'll go for relational operators. Generally, relational operators are useful to compare the data. This is also called comparison operators. This relational operator always gives the result either true or false. True or false. You can use greater than symbol, or you can use less than symbol, or you can use less than equal to, or you can use greater than equal to, or you can use double equal to, or you can use not equal to. So there are 6 varieties of relational operators. All relational operators are binary. All relational operators are binary. That means it will be depending upon 2 operands. Even last time, I think in exam also, they asked relational operators are what category? Relational operators are what category? Option A, unary, B, binary, option C, ternary, option D, none. So the answer is binary. Relational operators are binary. That means depends on 2 operands. Class relational demo. So just a simple demo. Putting public static word main string argument array. I am taking 2 value int a equal 10, comma b equal to 5. Now I will use the relational operators. System dot out dot println my result. This result I am concatenating with, I am putting within bracket a is greater than b. Then what is the answer? That means you are comparing a with b. 10 is greater than 5. Answer is yes. Yes means true. So you will get the true value. Control C, Control V. If I put less than, what I will get? 10 is less than 5. Answer is no. No means false. So like this you can compare. Similarly, you can check. This is for greater than. First one is for greater than. Result for greater than. This is result for less than. And now greater than or equal to. Greater than or equal to. And then less than or equal to. So you can use all 6 varieties. So there everywhere you will get what? The Boolean value. So in your application you may use any kind of relational operators. Similarly equal to and not equal to. So here we are comparing whether both are equal or not. If it is both are equal, it will return true. And not equal means whether both are equal or not, it will check. If it is not equal, return true. If it is equal, it will return false. Control S. So whatever the name of the class you have given, that name you will give. Relational demo. RELATION. Relational demo. And while choosing, you choose as Java. Press J, you will get the Java source code because this is part of your Notepad++. Yeah, relational demo. Save. Now go to the command prompt. Compile it. Java C. Relational demo. .java. Okay. Now Java. Relational demo. Yeah. Now what your answer? Either true or false. First one. 5 is greater than, sorry, I think we have given the value A is 10, B is 5. 10 is greater than 5. Answer is true. 10 is less than 5. Answer is false. 10 is greater than or equal to. Either greater or equal. Anything is true means true. 10 is less than or equal to. 10 is less than 5 or equal to 5? No. So false. 10 is it equal to 5? No. So false. 10 is not equal to 5? Yes, 10 is not equal to 5. So true. So relational operator gives the answer always true or false. Generally, relational operators are useful in a conditional statement or control statement. That means while writing if, else, switch case, there you can use these things or loop. But in this demo, I want to show what type of output you are getting. Whether you are getting a relational means a numerical value or Boolean value. So relational operator always gives you Boolean value, whereas arithmetic operator gives you numerical value. Okay. Next. We'll give logical operators. Control A, Control C, Control N, Control V. Here, I want to give logical demo. So, how many logical operators are there? There are 3 logical operators. That is AND. Next is OR. Next is exclamation symbol. Not. These are the 3 operators. But out of 3, all are not binary. Remember, AND is binary, OR is binary, but not is unary. Not is unary. OR is binary and AND is also binary. That means I can say logical operators are binary as well as unary. Means 2 binaries are there and 1 unary. Okay, fine. Now, I'll say logical demo. I'll change the name. Now, once you apply the logical operator, here also you will get the logical value. That means the Boolean value. Now here, I want to apply first AND operator. A and B. Similarly, A or B. And this is not of A. That means I can write A or B, but not both. Not, sorry. Because that is unary. So here, I will remove all these things. First one is AND. Second one is OR. Third one is not. For logical operators, you see the output. Control S. Logical demo. Logical demo dot. Now here I'll choose Java. Save it. Go to the logical demo. Go to the folder. Now compile it. Java C. Logical demo. .java. What you got? Error. Bad operand type for binary operator. So that means you are not allowed to use for this. A is a numerical data. B is a numerical data. So all numerical data is not aligned. You should apply for what? The binary means Boolean value. For Boolean value you can use. So for example, I may check A is greater than 2. That means what? I am getting a Boolean value. Similarly, here I'll check B is less than 5 or less than 6. That means what? Here I am doing some relational operation. This value I am comparing and doing the logical operation. That means what? Here I will get a Boolean value true, and here also I am getting some Boolean value either true or false. Now for Boolean, I think you know there is a truth table. Truth table. So I'll put in a comment the truth table. Truth table for AND. Truth table for AND operator. For truth table, AND is what? True and true. Answer is true. Similarly, true and false. Answer is false. False and true. Answer is false. False and false. Answer is false. So that means if both the operands are true, then only answer is true. If one of the operand is false, answer is false. So this is operand A. This is operand B. This is result. So the result based upon the A and B. Now, if you observe here, this is my first operand and this is my second operand. First operand is what? A is less than 2. A means how much? 10. 10 is greater than 2. Yes, true. B is how much? 5. 5 is less than 6. Yes. So true and true? True. So now I'll put this comment. This comment. Control S. Go to the containing folder. Now you got the errors. That error you have to overcome. There are 3 errors. Yes. Now there is no error. Because logical operators are applicable for Boolean data. You cannot apply for numerical data. Now how to run? Yes. The result of AND operator is true now for this data. If at all, assume I'll give I is some, I'll give 1. Now here 1 is greater than 2. No, and false. False and this is true. False and true, false. If I give now, it's supposed to be here. It's false. Because one of the item is false. False and false is false. So this is the way you can use. That means the logical operators are also useful for whenever you want to combine multiple conditions together. You want to take a decision by combining multiple conditions. So there you can use this one. Okay. Now let me apply same thing for Control C, Control V. I want to apply for OR operator. OR means double pipe. And here I'll write here OR. This display. This is for simply display purpose. Okay. Now A is how much? 1. B is how much? 5. 1 is greater than 2. No, false. But 5 is less than 6. True. So that what is that? I think you know the truth table for OR. The truth table for OR. Now we'll write the truth table for OR. This is for AND. Similar for OR. For OR, what is the answer? True or true? Answer is true. Next. True or false? In the case of false, if one of the item is false, the answer is false. Similarly, false or true? If one of the item is false, answer is really sorry. In the case of or, one of the item is true means true. True. Okay. Next, false or true? True only. If both of the items are false, then your answer is false. This is quite opposite of and. Control S. Now, I will go to the folder wherever the program is there. How to go to the folder? Right click, open into command containing folder, go there. Now compile Java C, followed by logical demo. The name of the program is logical demo. Compile it. Yes, compiled successfully. Java C, logical demo. Now click. Now it is error because in compiler you cannot do. So you have to use interpreter, that is Java. So you have to write this one. Yeah. So for or I got true, whereas for and I got false. So that means based upon the truth table I got the corresponding result. Next, not. So how to use not? Not is what? Unary. That means it is applicable for only single operand. So now here I can apply for not symbol. This I will apply. That means I will remove one of the operand. Here I am applying this. Not of this. Not of this. A is greater than 2. A is how much? 1. 1 is greater than 2. No, false. Negation of false is true. So, compile it. Again there is error. Accepted notation is explicitly requested. Java C, Java. Yeah, compile successfully. Java followed by logical demo. Yes, I got true for not operator. So that means you got different types of value for different operators. So in the coming days, we will be using these operators in the program. So today, try to know how to use these operators. So what type of value you are getting? So once you apply this logical operator, the answer will be either true or false. Based on the true false, you can take some decision, generally in the decision making statements. Okay. In the previous session, we have seen arithmetic operators, relational operators, logical operators. These three we have seen already. Now, the remaining operators, we will go through now one by one. Because once you know these operators, then you can write the program. So, I think in the previous session, we have discussed about the operators are of three categories: unary, binary, and ternary. Unary operator depends on single operand. Binary depends on two operands. Ternary depends on three operands. Now, today we'll start with one more operator called assignment operator. Assignment operator basically useful to assign the value, and its associativity is right to left. So now we write a program how to use these assignment operators with a small application. So we'll go to our editor. There we'll type the program. Let us see a program. So I'll open my Notepad++. In the Notepad++, I'll write the programs on assignment operators. There are different types of assignment operators are there. This part I am writing in my documentation section of the program. I told you for every Java program, the first part is always the documentation, the comment part. So in the comment part, you have to specify what exactly you are going to do. Now, assign demo. Okay. Now here, I'll write my driver code. That is my public static void main. This is the common statement. In the previous class, I told you the first keyword is always the public. It tells about you can access anywhere and it can be accessed by anybody. That is the public accessibility. Next, it must be called directly without creating object. So there is a keyword called static. And then this method returns nothing. Then write main means void. Then write your main method. Main method is your driver method. And this method, it may take some arguments from the command prompt. Those arguments always in string form. So there will be multiple arguments. So those arguments you can write in a string arguments array. See, this is the general syntax of the main method in Java. Now, what is my goal? To use assignment operators. How you can use assignment operators? First is simple assignment. Simple assignment is a simple equal to. It will assign the value from right to left. For example, if I write x equal to y, the y will be assigned to x. Y will be assigned to x because right to x, left. Similarly, compound assignment. Or shortcut assignment. Compound or shortcut. Shortcut assignment. The shortcut assignment can be written like this: plus equal to. One example. Plus equal to means what? This is the one. Also binary operator. X plus equal to y. The meaning is x will be assigned with the result of x plus y. So instead of writing x equal to x plus y, you can write x plus equal to y. Similarly, when I say minus equal to y, if I write x minus equal to y, what it indicates? The meaning is you can write x equal to x minus y. So this is the way you can write the statement. Similarly, the other operator, like for example, and equal to. And equal to means you can write x equal to x and y. So this is your bitwise and operator. So in a simple shortcut form, you can write this way also: x equal to x and y. Okay, this is called compound assignment or shortcut assignment. So those example now we'll see how it works. Now let us declare the variables int x equal to 10, comma y equal to assume 5 and comma z. So here what I did, I have declared three variables: x value 10, y value 5 and z. Now here the first statement is what? This is my initialization statement because I have initialized the value. So for initialization also you are using assignment operator. Now here I will write z equal to x plus y. That means what? I made the addition up to number. That result I am storing in z. So here which operator I have used? Assignment operator. The value of x plus y now has stored in z. Its associativity is right to left. Now let me print the value: system.out.println. Automatically the value of z will be printed. Put a semicolon. So this is a simple assignment. Now I want to use the compound assignment. So how to use compound assignment? The compound assignment can be done this way. If I write here z plus equal to y, what is the meaning? The meaning is here z is assigned with z plus y. So whatever the value of z is there already, in that z y is added. So finally you will get the latest z. Now let me print that value also. To print that value, what I have to do? Let me copy and paste. I am printing z. This is my original z. So here, while printing, you have to print string value. Again, I am printing the latest Z because after doing the addition, this value plus Z. But in addition to that, you may ask what is the value of X and Y. That value you want to print. So in that case, what you will do? I will print X value as well as Z value also. Means X, Y, Z. 3 value I want to print. X equal to. So while printing X equal to, write double quote. Plus, this means always you have to concatenate with X value. You are concatenating X value and printing plus. Plus means joining. Again, I am printing Y value also. Y equal to plus Y. Now please observe here. I am printing X value, Y value as well as Z value. Whenever you want to print multiple values, you have to concatenate by using plus operator. This is the value of X. This is concatenating with the value of X. That means within the double quote, whatever things you are displaying, that will display that value plus the value of Y that is concatenated. So now it will be printing everything in a single line. Now let us save the program. Assign demo. So here you can save Java, select the J. So once you save J, that is saved as with Java extension. Now my name of the program is assign demo, Control C. Okay. Go to the command prompt. How to go to command prompt? Because wherever the folder means the program is saved, go to that folder. You come to this assignment demo, the name of the file, right click, go to this open containing folder. Wherever the program is saved, go to that place. Okay. I think you are able to see now. Now compile it. Java C. Assign demo. Assign demo. Yes. Now there is a mistake. That means actually those statements are supposed to be in the comment. But here I have not given the comment because these are not part of the program. This is only for simplicity I kept. So those statements must and should be in the comment statement. So whatever the things I wrote here, this is for your understanding purpose. So I should put in a comment. I told you there are 3 types of comment. Single line comment, multi-line comment and documentation comment. As in this statement, you have to specify what exactly you are doing. So one line is enough. That's why I am putting in a comment statement. This is only for programmer understandability, not for the system. Now, Java C. Compile it. Java. Assign demo. And while executing, please do not give dot class. Yeah. What is saying? Assign demo is could not find. Why? What is the mistake? dir assi demo.star. Here assign demo.java. But what is the name of the file? This is assign demo. But name of the class? The name of the class is, oh, there is one M is there. That's why it is not recognized. So don't give this one. By name should be also saved. Control S. By class name and file name supposed to save. But while saving, I made some mistake. Means here the name of the class I made mistake. Now how to rectify? Again compile Java C. Because once you change the program, again you have to compile. Assign demo. Yes. Yeah. Now successfully compiled. Now if you see, assign demo.class has created. Now if I put star, yeah, always check whether this class name and file name are same or not. And by typing dir.star or class name dot star, when I give dot star, that will give all the file name starting with assign demo with multiple extensions. Now here there are 2 extensions. One is dot class, second is dot java. So this program is written by you, whereas this Assign demo class is created by the system. This is my bytecode. This bytecode I have to run. So how to run? Java followed by assign demo. Yeah. Now here, if you observe here, I got x value 10, y value 5 and z value 15. But here I have to give some space also. After 5, there must be space. So what I'll do? Go to the program. After 5, before that I'll give a space. Now you will find distinct space. Similarly here, Control S. Once you change, again compile, again run. Yeah, now you got what? Z value is 15 and y value is 5. In the last statement, if you observe here, how much z is coming? 20. How it is coming? Because I made, if you observe here, the statement was what? If you observe here, the statement is, I will show you line by line. Yeah. Our z plus equal y. That means I am adding z with y. What is the value of z? 15. Y is how much? 5. So 15 plus 5, how much? 20. So that's why you are getting 20. Okay, that means this is your compound assignment. So in a similar way, you can execute other statement also. Now, here at this point, z is how much? 20. Now if I write z star equal to, if I write 2. Now what happened? This is nothing but z equal to z into 2. This is nothing but z equal to z into 2. Okay. So as this statement is not required for you, so I'll put in comment. Means for the system not required. And how to print the latest z? I want to print the z value. Control V. This is after multiplication. After multiply. After multiply. Fine. Control S. Now compile again. For every changes you have to do compilation. Java C. Assign demo. Yes, compiled it. Java followed by assign demo. Yes. Now after multiply, because the latest value of z is 20. Now here how much you got? 40. Is it clear? So this is the way you can use the compound assignment. This compound assignment is also known as shortcut assignment. So you can apply all types of assignment statement in your application. So day by day, we will be using various types of assignment operators. Okay. Now we will go to another operators. That is your bitwise operator. This is the main one. You should know how it works. Okay. This part will write through a small Java program. Control N. I will create a new window. And my goal is to perform all bitwise operators. The bitwise operators are the special operators, basically useful whenever you are using the bit level operation. Generally, bit level operations are useful during the image processing or networking application. So because in image processing as well as in networking application, it requires the data always in bit form. So whenever you want to do the operation at bit level, that time you have to use bitwise operators. So let us take a small application where you can use these bitwise operators. And remember, before doing this bitwise operator, you must know the truth table for all operations. Especially, so I want to know the truth table for AND operator. This AND operator is also known as bitwise AND. So please remember, actually Java supports two AND. One is logical AND. In logical AND, you have to write double ampersand. In bitwise AND, you have to write single ampersand. So before applying this AND operator, you should know the truth table. Assume A is one operand, B is another operand, and if you apply A and B, assume A is true, B is true, then true and true, answer is true. Okay. Next, A is true, B is false, true and false, answer is false. That means in and, if both are true, answer is true. If one of the item is false, answer is false. False and true, answer is false. Similarly, false and false, answer is false. So this truth table you should apply while writing the program. This is the one you should know. Of course, you will be knowing even in the intermediate or school level. Let us apply this. I will put all these things because this is not required for the program. This is only for the programmer purpose. So I will put this in comment. This requires multi-line comment. So I will put this. Single line comment means it takes more time. Now we will write a program for this. So class bit demo. So the name should be relevant to the task. So always remember, whenever you are writing a program, the program will use set of classes. The class name should be relevant to your task. What exactly you are going to do, that name must be given in the class name. Bit demo. Control S, saving the program. And here I will choose J. So select J, Java file. So automatically the file name will be stored with the extension .java. Program save. Now I'll write my driver method. So how to write driver method? Always the first keyword is public, next is static, public static void, then main, then string array, means you may pass set of arguments from the command prompt. This is the basic syntax of any Java program. From this point onwards, you have to write your own logic. Here my requirement is to use the logical operators, bitwise operators. So bitwise operators generally works on the numerical data. Because this numerical data will have some numeric value which is internally stored in again binary format. That binary data I want to operate. So let me declare the three variables A, B, C. Okay. Assume A is 10 and B is some 5. And I want to compute C. C equal to A and B. Now when I write this statement, here what I wrote, bitwise and. Single ampersand means bitwise and. So whenever you write this way, automatically what will happen? This will be performing in this way. Let me evaluate. Here I wrote how much? A is 10, B is 5. A is 10, B is 5. So 10 means what? 10 is the numerical data, but internally the 10 will be stored in the binary format. Binary means 1010. That is binary format. Similarly 5. 5 is my numerical data. Means in decimal form. But what is the binary equivalent? The binary equivalent of 5 is 101. And here always the left hand side data by default automatically will be 0. The previous value will be 0. So now when I do AND operation, what I will do? 0 and 1. 0 means false, 1 means true. False and true, answer is false. False means internally 0. 1 and 0. 1 means true, 0 means false. True and false. True and false means false only. False means 0. 0 and 1. 0 means false. This is 1 means true. 0 and 1. So 0. 1 and 0. 0. So my result is 0. So my result will be convert again into decimal data. So its decimal equivalent value is 0 again. Okay. Now let us go to the program. Now here I will print the value of C. So finally system dot out dot println and the value of C I want to print. Now C is storing what? The resultant of A and B. Now when I print C, what I'll get? I'll get 0. Now control S, my program is saved. I'll go to my the respective folder. How to go to the respective folder? Come to open into containing folder command. I will compile it. Java C bit demo. Yes, I got compiled completely. There is no mistake in the program. If at all any mistakes are there, it will come error. Now Java bit demo. Yeah, I got 0. Now let us take a different value. Assume instead of 10, let me take 15. 1 5. If I take 15, then what is the answer? 15 means what is the value? 15. Its equivalent value how much? 1 1 1 4 ones, that is 15. Then 5. 5 means how much? 1 0 1. As I want to balance it, always the previous value we append with 0. Now when you say AND operation, 1 and 1, always answer is 1 because true and true, true. 1 and 0, that means true and false, 0. Now 15 and 5, we are doing AND operation. So when you say AND operation, what will happen? 15 means 4 ones. 5 means actually 1 0 1, that is the binary value. And as I want to make it to balance, so I will append 0 at the back side. So now both number will have same number of digits. When you say AND operation, 1 and 1, 1, 1 and 0, 0, 1 and 1, again 1, 1 and 0, again 0. So that means finally you got how much? 0 1 0 1. 0 1 0 1 means again the value is 5. So finally the 5 will be stored in my variable C. Okay. So now let us go to the program. How the value comes. Now you can observe here, because here I made A value 15, B value 5. Okay. A value 15, B value 5. And I am computing how much? C equal to A and 5. So now when you are printing, I'll get this. Fine. Now let us go to the program. Control S, save the program. Come to the command prompt. How to go to command prompt? Come to right click. Open information containing folder CMD. Now Java C bit demo dot Java, because while compiling you would give the dot Java extension, and while running you would give only name of the class, that is bit demo. Yeah, now I got C value 5. So after performing the operation, again it will convert the data into decimal form. The decimal equivalent is 5. So this is the way you can compute. Similarly, other operations. Let me operate the OR operation, XOR operation, left shift, right shift, as well as triple right shift and ones complement. All the value I want to compute. So those value I want to store in different variable. So let me declare the variables like D, E, F, G, H. So multiple variables I have declared because I want to store the value in different variables. Okay. So let me compute OR operation. How to calculate OR? So C equal to A or B. Similarly, I will compute the XOR. Sorry, let me store in D. Next, E equal to A XOR B. So please remember, this is first one is AND, second one is OR, and third one is XOR. XOR means exclusive OR. Next, F is how much? F is A right shift B, or A right shift 2 bit I want to shift from right side. This is right shift. So generally in the bitwise operator you will be doing various types of operation. Either you may be doing overlapping of 2 bits, or you may be shifting the bit from one angle to another angle. So that time you may use this shift operator. Either you shift right side or you can shift left side also. So whenever you are shifting left side, so you can use left shift operator. Store in variable G equal to A left shift, assume 2 bit, and then H equal to assume A triple right shift 2. Okay. So you can apply even unsigned right shift. So always it maintains the positive data. Whereas this right shift is, it is signed right shift. This is signed. It will maintain the sign. It will maintain the sign. Whereas this is unsigned. Unsigned right shift. Unsigned right shift. That means always it maintains positive A, positive format only. Unsigned means no positive symbol or negative symbol. When nothing is there, automatically it is positive. Okay. Now, let us have this is left shift. So this left shift and right shift are always maintaining their sign. Positive means positive, negative means negative. Whereas in unsigned, always it maintains positive only. Because internally, when the negative values are stored, that will store in, there are different format, signed magnitude form or 2's complement form. So based on that one, always in MSB, for negative data, 1 will be stored. So this 1, it has to maintain in general right shift. Whereas here in the unsigned right shift, that 1 will be removed. Because once you shift right side, 1 will be removed and 0 will be appended. So it will become a positive form. It will become a positive form. So let us take a simple value. Assume A value is, I am taking 8. B value is, assume I am taking 3. So let me take a small value so that it is easy for you to understand. And 8 and 3. 8 is one value, 3 is another value. When I say 8 and 3, now 8 is how much? 1,000,000. So let me show you a window. 8 and 3. Here I want to do first OR operation. OR means if one of the bit is true, answer is true. 8 means 1,000,000. 3 means how much? 0, 1, 1. And as I want to make it balance, I will put 0, 1 at the backside. Because appending 0 at the backside, there is no difference. When you say OR operation, 0 and 1. Sorry, 0 or 1. So answer is 1. 0 or 1, 1. 0 and 0, 0. 1 and 0, 1. So you got how much? 1, 0, 1, 1. So 1, 0, 1, 1 means what? This is 2 to power 0 position. This is 2 to power 1. And this is not there. This is 2 to power 2. That means how much? Sorry, this is 0, 1, 2. This is 3. So 2 to power 3 means 8. 2 to power 1 means 2. 2 to power 0 means 1. So answer is 11. So remember, to evaluate this one, there is a formula called 8421 formula. 8421. So whichever bit is enabled means 1, you take that value. Here 1 is there. So automatically 1 is enabled. 8 is enabled. 0 means don't count. Then 1, 2 is enabled. Then 1. So 8, 2, 1. So answer is 8 plus 2, 10, 10 plus 1, 11. So answer is 11. So my answer is 11. So if I execute, I will get 11 for OR operation. So when I write C equal to A or B, so my C will be 11. This is the way it works. Now, similarly, XOR operation. So I will show you the output also. In XOR, the bit will be different. 8 and 3, I want to XOR. In XOR, if both bits are different, then value will be 1. If both bits are same, the value will be 0. So, XOR operation represented by cap symbol. So, 8 means how much? 1,000,000, that is 8. 3 means how much? 0, 0, 1, 1. Now, both bits are different, 1. Both bits are different, 1. Both bits are same, 0. Both bits are different, 1. So, 1, 0, 1, 1. So, my answer here also 1, 1. So, 1, 0, 1, 1 means same. Here also I will get 11 only. Okay. If total I take, for example, 7 and 9. XOR operation. If I do 0, 111 is the 7. 9 means how much? 1, 0, 0, 1. 1 and 1. Both the bits are same. So 0. 1 0 1. 1 0 1. 0 1 1. So you have how much? 1110. So 1110 means first one is what? 8 plus 4 plus 2. So 8 plus 4 plus 2. So answer is 14. So 14 will be the answer if I am taking 7 and 9 for XOR operation. So let us show this output through a program. Let me go to the program. Yeah. Now let me print the value of C, D, E. So I'll print C, D, E, F, G. All value I'll print C, D, E, F, H, E, F, G, H. Okay. So what output you are expecting? Can you guess now? For C, you are supposed to get how much? Because you are doing 8 and 3. So when you say 8 and 3, already you have evaluated. That is 11, I think. You got 11. And for D, how much you will get? Because here also you are getting XOR operation. And the value of A is how much? 8. 8 is 111. Means sorry. 1 0 0. And 3 is 0 0 1 1. So when you say operation either bitwise AND or XOR or left shift right shift, you can evaluate now. So here you can evaluate now. Now guess this value. 1 and 0. For AND you get 0 because all values are different. So this is AND. So for AND you will get how much? 0. 8 and 3 you will get 0 marks. Means 0 value. Fine. For AND you will get 0. Fine. And for OR, because both bits are different, means here for OR we will get how much? 1 0 1 1 1 0 1 1. So for OR you will get, because 1 0 1 1 is nothing but 11. 11 means 1 0 1 1, that is 3. 1 0 1 1, that is the equivalent of 11. Already I have shown you in the previous slide how to evaluate. So this value I am printing. And for XOR, when both bits are different, you will get 1. When both bits are same, you will get 0. So here now how much I will get? Both bits are different. 1 0, again 1, again 1 1 0 1 1. So here also I will get how much? 11. So let us run this term up to E. Let me print so that you will have more idea. This one I will put comment. I will not print now. Okay. Yes. Now compile it. Java C bit demo. Compile it. Java bit demo. Yeah. So C value I got how much? 0. And D value how much? 11. And D? C, D. So whatever the value you have expected, same thing the system has given. Okay. So this is the way you can compute. So you should know the binary value. Once you know the binary value, you can do the operation. At the same time, you should know the truth table also. Then we will compute these three. These three are what? Left shift, right shift, and unsigned right shift. So for this, there is a simple formula. If you are doing left shift, the formula is A into 2 to the power b for multiplication. Okay, when you are doing a left shift b, that is nothing but equivalent to multiplication of the data. A left shift b is equal to a into 2 to the power b. Similarly, for right shift, you can write like this: a right shift b is equivalent to a divided by 2 to the power b. A divided by 2 to the power b. So you can compute this value and get the value. Now let us compute F is your left shift. F is left shift. And G is right shift. Okay. And your H is unsigned right shift. Sorry. I'm real. F is right shift. F is right shift. And this is left shift. This is unsigned right shift. Okay. Now let us run. Clear the screen. Java C and bit demo .java. Yes, compiled successfully. Now followed by bit demo. Yeah. So how much you got? F is, because A value is 8, B value is 3. 2 to the power 3. 2 to the power 3 is, now here the right shift F value. Actually A value is 8, B value is 3. So for F, how much you will get? Because F is right shift. For right shift, you will get 8 divided by 2 to the power 3. So 2 to the power 3 is how much? 8. So 8 by 8. So let me put this as a comment so that we will not have any confusion. Control S. I am printing F value, G value. Here F value is how much? 2 here. That means here we are doing 2 to the power 2. So 2 to the power 2 means how much? 4. So A value is how much? A value is 8. So 2 to the power 2 means 4. This is nothing but 8 by 4. 8 by 4. 8 by 4 is 2. So right shift value is 2. Okay. Similar left shift. Left shift is what? The left shift value is nothing but, because you are computing 8, left shift of 2 is nothing but 8 into 2 to the power 3. 2 to the power 3. So 2 to the power 3 means, not 3, that is 2. So this is how much? 8 into 4. So 8 into 4 means 32. Okay. Now, yeah. So here you got 32. And unsigned right shift and right shift almost both are same, because both have the positive sign. There is no difference here. When the value is negative, then you will find difference between unsigned right shift and signed right shift. Now, let us take a simple example for unsigned right shift. If I assume A is minus 8. A is minus 8 and B is 2. Now I want to compute C value. C equal to A right shift B. Now in that case you will find the difference, because now actually in the case of positive value always you will get the positive. In negative, for unsigned right shift you will get again positive data. So you observe here, for unsigned right shift of Unsigned right shift means triple. Now compute the C value. Now compute the C value. Unsigned right shift of C means triple. You're getting in C value. Control S. There you'll find how difference. Compile it. Yeah, you got a very large value because it has converted to positive form. Because that most MSB bit, most significant bit, that one has gone towards right. Now it has again converted into positive value. So in unsigned right shift, always you'll get a positive form only. There is no negative data. Whereas same thing if I apply for positive means normal right shift single. Now here I will remove this. How will get? There will find the difference. Control S. Let us see how they are differ. Compile it. Run it. Yeah. Here you got how much? -2. We got 2 to the power 2. That formula is applicable for this. So this is same data with unsigned right shift. This is the same data for signed right shift. This is the way you can differentiate between signed right shift and unsigned right shift. And one more operator is there. Once complement. Once complement. That is tilde symbol. In once complement, it will convert the bits from 0 to 1 and 1 to 0. And the value you can get also. For example, I may print data in once complement form. Once complement form of A, right? What is the value of A? A is, assume, here I'll write A equal to some 10. Its complement form is represented by in this form. So, it will convert the data first into binary form, then 0 become 1 and 1 become 0, and you will get a large value. Compile it. Yeah. And finally, this here once complement. Once complement. Okay. Control S. Yeah. How much you got? -11. So for that also there is a simple formula also how to know how we will get -11 or -10. So the formula is minus of the num plus 1. Num plus 1. Num means how much? 10. Or I can say minus of A plus 1. A plus 1. If at all I give assume, I may give A equal to 23. Then what is the once complement? Then what is the formula? The formula is minus of A plus 1. If I ask you what is the once complement of A now? Now here A value is how much? 23. A equal to 23, but its complement is how much? 23 plus 1 of minus. That means A plus minus of A plus 1. Control S. So I'll get how much? -24. I'll get -24. Compile it. Run it. Yeah, I got -24. So this is the way you can compute. So the formula is minus of A plus 1. So apply this formula and do this. So this is the way you can solve all the binary operations. Okay. So in future application, you will be using various types of operators also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.